All right, friends and neighbors, welcome back. We are moving through Chapter 3 in CCNA Volume 2, Advanced Access Control Lists, or what is sometimes called Extended Access Control Lists. This video will go over the key topics for the chapter. The exam section, of course, is Security Fundamentals, configuring and verifying access control lists. And as a reminder, the access control lists that we've been working on or we've been talking about are the standard, extended, named access list, and then along with those we get sequence numbers and our ability to do a little bit of editing. And we'll polish off with the do I know this already questions. So our key topics, syntax and notes about the 3 required matching fields. I've got an image for you on that one. A summary of extended ACL logic. Turns out that it's very similar to standard ACLs, except that we have more fields that we get to deal with. Syntax and notes about matching TCP and UDP ports. We're going to do some demos with the TCP and UDP ports, but the layer 4 ports are among the things that are now extra, things that we didn't use or didn't deal with in standard ACLs. Logic and syntax for matching, same guidelines for using extended numbered IP ACLs. We'll do some examples there. Differences between named and numbered ACLs when named ACLs are introduced. So we've got a couple of configuration differences that we'll talk about. Now, the cool feature that's enabled by ACL sequence numbers is among other things, our ability to look at individual lines based on a number that goes with the filter rule, and our ability to add and subtract and insert them wherever we want. And then lastly, we'll talk about some ACL implementation recommendations. All right, now extended access list. It's really easy to sort of go, oh my goodness, there's a lot to remember, but they work exactly like standard ACLs. So we have all of the same things plus a couple of extra features. So they've got first match logic, right? So whatever rule gets matched first, that's the one that gets accepted. It doesn't matter if you said, well, I want to match number 3 instead of 1. We have to match all the fields in the rule. So if a packet comes in, it's not enough that it matches part of the rule. It's got to match the whole thing. And then, of course, we compare this against the list of rules. So we can have an awful lot of rules in the ACL. And even though we're doing first match logic, if it doesn't match the first rule, it goes to the second one, and so on. So each packet is tested against all rules until either a match is found or the list reaches an end, in which case the packet is just dropped. We cannot forget our interface and direction. That's always really, really important, and especially when we start talking about implementation, one of the first things that we think about is where are we going to put this thing and what flow path are we looking at? Now, the big difference between extended ACLs and standard ACLs is that we've got more fields to deal with, and most notably, anything that's not a source IP address. So if you look sort of right above me here, this is an IP packet capture, right? I've just taken an image of an IP header. And we can see there's the source and destination IP address fields. Now this one happens to be DHCP, so the source address is all zeros. We can see that we've got the source address field, and this is the one that standard ACLs were worried about. Now what we're going to add to this is the destination address, and then we've got this protocol field, or PID, the protocol ID. And the ones in yellow here are highlighted because these are the ones that are required for extended access lists. Now we've got other things that we can look at as well. We can look at the type of service or the class of service, the differentiated services code points that are set in the IP header. And then we can forget about the IP header entirely. We can move up to layer 4 and look at the source and destination ports that exist for either TCP or UDP. So those are our big ones. But the required ones are going to be the protocol ID and the source and destination IP addresses in the IP header. Now there are a couple of other things we want to remember. We still have keywords, but we have more fields where those keywords can be used. There's a little bit of weirdness. The standard ACL doesn't require the host, but if you specify a single host in an extended ACL, you have to use the keyword host. And we can't forget that implicit deny all. Remember that if something's not permitted, it's automatically denied at the end, which is why if you exhaust a list of rules without finding a match, Packet is automatically dropped or denied. Now, table 3.2 in the chapter provides a couple of examples. So here's a basic syntax, right? So what we're going to do is specify the access control list rules. Now, the extended access lists number from 199 and 2000 to 2699. So there's two ranges of IP address, so that's why all of these examples start with 101. So they're in the range of 100 to 199. So our basic syntax is to state the number. Now this is again a numbered extended access list. And so the first thing that we say is, what is this rule going to do if there's a match? Well, it's a deny right there. And then we're going to specify the protocol and then the source and destination IP addresses. So that's what these are. And of course, any was an example of one of our keywords. Now here's another one where we permit a particular IP host. There's the required use of the host to another host. So again, we've said here's our protocol ID, so any IP packets, and then this host to that host. So again, source and destination IP address. And here are a couple of other examples, right? We're not going to forget that we can use our masks along with this, right? Our wildcard mask. But whatever you put in the rule, each rule, all of those fields have to be matched or we're going to move on to the next rule. So that's really, really important to remember. Now, if your protocol ID is, say, just IP, well, then you have the source and destination IP addresses to worry about. But the minute you use a keyword like TCP, that opens you up to the ability of using match criteria that's based on the port numbers. So we have a couple of options when we're dealing with port numbers. We can say, I want to match an exact port number, right? A port that's, say, HTTP or port 80. And then there are some built-in names. So there are some commonly used names, FTP, www, that are also available for use if you don't want to use the number. And then we can also have some logic that says, I want to allow port numbers that are greater than or less than or equal to these particular port numbers. So it's nice to have those available to you if you're trying to specify a range of ports. We have to remember our packet flow directions. So I've got a graphic down here at the bottom. And if we consider the packets that are flowing from PC0 over here to this server, so the direction is from the PC to the server, then we might want an access list like the first one here, access list 101 permit TCP, right? So now we're saying here's the protocol that I'm worried about. Anything from the 1 net to the 3 net, as long as it's equal to port number 21. So that's TCP port 21. Now, if I see anything else, right, if there's any other arrangement, then this won't work because this is highly directional. It's the 1 net to the 3 net, and it's TCP going to port 21. But if we're thinking about flow the other way, then the next line might match. Access list 101 permit TCP 172.16 3 net to the 1 net, so it's flowing from the 3 net to the 1 net. And in this case, we're going to be looking at TCP again, but remember that in this case, the source port will be 21, not the destination, because this will be traveling on its way back. So directionality is really, really important. Now, these could be applied at different interfaces depending, again, on the direction that you're looking at and whether or not you're going in or out of a port. So if we just use the example of the first rule here, flowing from the 1 net to the 3 net, I could apply it on the inbound direction on our first interface or the outbound direction on the next interface, the inbound direction on the next interface, and the outbound direction on the last interface. Flowing back the other way would be the exact opposite. So some configuration details, same ideas as standard ACLs, right? Think about your location and direction. That's what we just talked about. Place the ACLs as close to the source. That will be filtered to save bandwidth. Now, I've got a little asterisk here because what we're talking about is denying. So if I'm killing off traffic, then I want to kill it off as close to the generator as possible. If I'm permitting traffic, I might look at it a little differently. The extended access lists are numbered 1 to 199 or 2000 to 2699. So these are our two sets of rules. We could use either one of these for extended access lists. And then, of course, to apply them, to actually get them to work, we need to do the IP access group command on an interface and direction. Now, there are lots and lots of options in the syntax. This is just one example of syntax that's available for an extended access list, right? So we do access list and then 101 and so on and so forth. So here's a couple of more examples here where we've used the equal to and then less than keywords here just to show you a little bit more about how you can do that. So here is deny TCP, any IP address, and then ports that are greater than 49,151 going to this particular host equal to 21. So we're killing off TCP ports above a certain range, as an example. Okay, let's do a couple of examples of numbered ACLs. So here we have a small topology, and we're going to focus on our router 0 here. And what I'm going to examine, again, is traffic that might be flowing in this direction here. So we'll be focusing, mostly here, but we're going to do extended instead of standard. So as we know, we're going to do access list 101. And then what are all of our options? Well, we got to start with our permit or deny. So what I'm going to do is say permit. Now I'm going to take a look at PC that's 172.16.1.2 first. So the next thing I need to do is specify my protocol. Now if I want this PC to be able to do anything, for example, I might say, well, the protocol is IP and what now? Well, I'm going to go to a source. Now I could use wildcards. We'll use all of the options that we can in a single command here. So we're going to say host 172.16.1.2, and then the next part of this is where am I going? So here we got another similar set of commands. So I'm going to say host 172.16.3.1. That's a PC on the other side. One of the questions in the book is what happens if I want to see these but I haven't done anything, right? So if I haven't, I've forgotten to save my configuration. I can say show access lists, and there they are. Oh, I've got another access list that I was fooling around with. We'll do that one here in a little bit. So here is the access list that I just created, right? But it's not actually doing anything. There's nothing applied here. So if I do a show run, it won't hurt you to see these other ones. You can see that I don't have anything applied here. Well, what do these look like in configuration? So, well, here's a couple of them. Here, this is access list 101, and then I've got access list 1. That's a standard ACL, and then a couple of named ones. We'll fool around with those later. But of course, to get this to work, I need to apply it. So right now, both of these PCs can ping the destination. Okay. So let's actually apply this. So I'm going to say int g0/0/0. Now I'm thinking about direction, so I'm going to do the in direction of g000, and this is close to the source for denying traffic that I might not want. But in this case, of course, we're permitting one host. So I'm going to say IP access group 101 in. Now we've got this applied. What's the impact? Well, we can see that our lower PC can still get there, but all of a sudden our 1.1 node is being told destination unreachable. Well, let's add another extended access list line that permits at least ICMP traffic from that node. So we're going to say access list 101, and what do we got to do, right? Same thing, permit, and then I'm going to change the protocol here. We can see that we've got a lot of protocol choices, so I'm going to say ICMP, and we'll say host 172.16.1.1 going to host 172.16.3.1. All right, now what's the impact here? What do my lines look like? Well, this is the line that I just added. Let's see if this works. And all of a sudden we can now ping. So the reason that this works is because when the router gets this particular packet, it says, I've got filter rules, and this is ICMP traffic. Do I have a rule that matches ICMP from this host to this host? Turns out that I do. Now, the reason this other host is allowed to ping, even without me specifying ICMP, is because I said you can do IP traffic, IP packets of any kind. Now, one last thing we can do is the traffic generator. So what I'm going to do is send TCP traffic. So we'll send FTP. So the destination address 172.16.3.1. So what I'm going to do is generate TCP-based packets of a particular port number, and we'll pick a non-system port. So I'll just go with 9999, and we're going to go to port 21. And then we'll do periodic, and then we'll send these. Whoops, forgot the interval. We'll send them every second. It's kind of tough to tell what's going on here, so we're going to run our simulation. And if we watch what happens, we can see the host is sending a TCP packet, which is our FTP, and it goes out to the router, and the router shuts it down. The router says ICMP destination unreachable. And what we're trying to do is send this across to the other side. So what we now need is a rule for TCP-based traffic. So I'm going to say access list 101 permit. Now we're going to do TCP, and I'm going to say, well, we'll go ahead and use a wildcard here, or a wildcard mask, and we'll say 172.16.1.0. And where are we going? We are going to 172.16.3.0. And we'll need a little more room. We can see that the rules can get quite long. And I'll say equal to 21. So what this is saying is that I'm going to be generating TCP traffic from this IP address range to this IP address range, and the destination port is going to be 21. So now if we take a look at our simulation again, we can see now that the TCP traffic gets all the way across there. Okay, so that was extended access lists, but they were numbered. Now let's talk about named ACLs and a little bit of editing. Now, the minute we use named ACLs, the interface changes a little bit, but we haven't gotten any new additional features. But it's a different way to think about your rules and a different way to view your rules and maybe do some editing. So the named ACLs enter right into ACL subcommands rather than editing all at the global level. So instead of doing access list 101 permit, access list 101 permit at the global level, we're going to say we're going to do a named ACL, and then we're going to drop into a submenu. So there are a couple of differences here. Instead of saying access list 101, we're going to say IP access list, and then the type of access list, and then its name. And that's the way that we're going to go about things. And we'll see that here in an example. So a standard access list would look like this line here, but then if we did a standard named access list, it would look a little different. And the same thing is true with the extended access list, but now we're going to say IP access list extended and then whatever the name is. Now, one of the important things here is that when I do this extended IP access list standard Bruce or extended Bruce, we can see that we get a couple of different options for the very next field. So this also shows us the sub interface. But a really important detail here is the sequence number. So that becomes really, really important for us when we want to edit. And we'll see what that looks like here in a sec. Now, editing ACLs can be quite a pain. It used to be that the minute you edited an ACL, like I was just doing, the whole ACL would be deleted. But we can see the iOS has adapted a little bit to that. But now we're going to add sequence numbers so that we can insert or delete right where we want to go. And we can also use automatic sequence numbers, or we can specify the sequence numbers that we want to use. Now, once you're in that sub-interface, new iOS implementations, I believe the chapter said past 15, allow you to mix and match sort of traditional styles of editing with the newer styles of editing. So here's an example. This is the one that you saw. These are screenshots right out of the config that you just got a peek at. But extended IP, so this is just a show access list. So extended IP access list Hartpence, and then we've got all of our rules. But the fun part is that we get these sequence numbers. Here is showing the 10, 20, 30. Those are automatic. The 999 is one that I wanted. Now for editing, we can see that I can delete one just by referencing the sequence number. And then when I take a look at my access list again, it's gone. So let's take a quick look at that. So if I want to do a named ACL, I would do IP access list. And then what I got to specify is the type that I'm going to use so that the sub-interface knows what commands to offer, right? So these are my two options here. So I'm going to say extended, and then I got to give it a name. Now I could give it a number, right? But then we're right back to where we were before. So let's use a name, and you saw that I was using Hartpence. But take a look at the sub-interface commands now, or the sub-ACL commands. And then here I have all the things that I'm used to seeing, except that I have this additional sequence number. Now let's pretend for a sec that I had a whole bunch of hosts over here. How would I add a host going to the same destination? Well, I might say, let's insert a line here. I'm going to say 11. Well, that's my sequence number. What do I do? What do I do after that? Oh, at this point, it's the exact same that we're used to. So 11, permit. Then I'm going to say host. Now this host doesn't actually exist, but it doesn't really matter. Oops, we got to do the IP hosts and then host 172.16.3.1. Now if I just say permit IP host 172.16.1.4 to host 172.16.3.1, right? It took both of these commands. One of them, I said what the sequence number was going to be, and one of them was going to be automatically generated. Let's take a look at what that looks like now. So if I do a show access list, well, what did we do? So this is the one that I was just working on. Here you can see that the line was actually inserted, right? Because I specified a sequence number that would go in between those. Where I didn't specify a sequence number, it was added to the end with just the standard increment that's used. Now let's say that I made a mistake. So I might say, whoops, I might say IP access list extended Hartpence, and then just say, oh, I didn't want that one that I numbered 11. I can just say no 11. And what happens then? We can see that it was removed. So editing with sequence numbers is something that's very handy to remember. By the way, you can also use show IP access lists to get the similar output. And then just for fun here, your output will also show you how many packets match your particular lines. Remember that 101 is the only one that was actually applied anywhere. Okay, access list considerations. Remember that when we're killing off traffic, place the extended ACLs near the source to be filtered to discard the packets early as possible. Place standard ACLs close to the destination so that you avoid unintentionally discarding packets that should not be discarded, right? If I created a rule that killed off a whole bunch of traffic with standard ACLs, which is easy to do, then I may accidentally stop traffic that's not supposed to be stopped. Number 3, place specific statements early in an ACL, you're less likely to make mistakes with first match logic. So if you just said, allow all TCP packets to any IP address in the world, well, you might let stuff through that you don't want through. But if you have some very specific things that you wanted to deny, put those up front and they'll be picked up with first match logic. Now, if you're going to do a lot of editing, disable the ACL on its interface, so no IP access group, before making changes. And this prevents added rules from dramatically impacting traffic. It also prevents you from accidentally activating an ACL that you forgot to remove from an interface. Now, these first two are we're talking about denying traffic. If you're permitting traffic, you might actually consider flopping those rules, but that's not what we're worried about here. Okay, the did you or do I know this already questions. Which of the following fields cannot be compared based on an extended IP ACL? Well, that was pretty straightforward. We know that it's source and destination IP address, protocol ID, the type of service or the DSCP bits, and then the port numbers. The URL and FTP file name are not part of those. Question number 2, which of the following access list commands permit packets going from host 10.1.1.1 to all web servers whose IP addresses begin with 172.16.5? And the correct answers there were A and E. They had the correct numbers for the extended ACLs, 1 to 199 or 2000 to 2699, and the syntax was correct, right? The fields were in the right order. Question number 3, which of the following access list commands permits packets going to any web client from all web servers whose addresses begin with 172.16.5? This is the same question earlier, but flopped around. So the only one that matched there was E. Again, correct number, right? 2000 to 2699, and then correct field orders. Question number 4, in a router running a recent iOS version, right? So that's 15. An engineer needs to delete the second line in ACL 101, which currently has 4 commands configured. Which of the following options could be used? Well, you could get rid of them based on the sequence number, like I just did, or you could kill off all of the ACLs and then put the ones back that you needed. Those are the only options in that particular question. Question number 5, refer to the following command output, which details an ACL enabled on port G0, 0, in the inbound direction, which answers lists a configuration mode and command that would result in the deletion of the line that matches 172.16.1.0. So, this is the line that we're worried about right here, right? We could delete that sequence number right there. But if we also dropped into the named ACL, we could also use a very traditional no in front of the entire line, and that would do it as well. So that was C and D. And lastly, an engineer configures an ACL but forgets to save the configuration. At that point, which of the following commands display the configuration of an IPv4 ACL, including the line numbers? Well, we just did that, show access list or show IP access lists. All right, in the chapter 4 look ahead, this is the end of part 1 in the book. So there's a couple of chapters that go together. We're now going to start part 2, which is security services. So we'll do some security terminology. We'll go over common threats such as man in the middle, DOS, buffer overflow, and several others. We'll talk about controlling and monitoring user access and developing a security program for education of your user and maybe a policy. All right, this has been more security, but with extended ACLs this time. Remember that we did both numbered and named extended access lists. The big fields involved in extended ACLs, protocol ID, source and destination IP address, port numbers, sequence numbers, and those sequence numbers give us some much easier editing rules. Well, like and subscribe for more security stuff. May those packets always reach their destinations with named or numbered ACLs. And hey, this is CCNA. You can do this.